going to start with question 2 because we have already done question 1. So let's go straight to question 2. This is question 2, 2.1. Prove that in any arithmetic series in which the first term is a and whose the constant different is d, the sum of the first n term is Sn is equal to n divided by 2 all into 2a plus n minus 1 all into d. Therefore 2.2, calculate the value of the sum of 50 terms when you start k is equal to 100 minus 3k. 2.3, you say that a quadratic sequence is defined with the following properties. T2 minus T3 is equal to 7. 2t minus T1 is equal to 7. 2-3 minus T2 is equal to 13. T4 minus T3 is equal to 19. 2.3.1, write down the value of A, T5 minus T4, B, T70 minus T69. 2.3.2, you say that we have to write down the value of T69 if T89 is equal to 23,594. So let's start to find the solution for this question. Find the solution. Okay, in 2.1 they said we have to prove that the sum, the Sn is equal to n divided by 2. We have to prove that the sum Sn is equal to 2n divided by 2 all into 2a plus n minus 1 d all into. So we know that this is an arithmetic sequence. This is the sum of the arithmetic sequence. To prove the sum of the arithmetic sequence, you have to add all the terms occurred in that series. So let's start. The sum of the arithmetic sequence is equal to the first term. We call the first term is a. To find the second term, you say a plus d. To go to the second term, say a plus d. Go to the third term. You say a plus 2d. So now we have 2d. We have to add 2d. This is the third term. Plus dot until to the last term, the general formula that you know of the arithmetic sequence, which is a plus all into n minus 1 d times by d. This is the general formula until to the last term that we call tn. So when you add this, all the sum of this arithmetic sequence, you get this formula. But we have to show that how do we get that formula. So Sn is equal to, you start with the last term. Start with that last term and come back up until to the first term. It's the same thing. The first equation. This is the first equation. So let's do the second equation. Will be a plus what the last term? A plus the general formula, a plus n minus 1 d. This is the first term. This is t1 and this is t1. This is t1. This one plus come back to the, when you go back from this term up to, going back you will find a all into a plus all into n minus 2 because negative 1 is greater than negative 2. Close the bracket d plus dot 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 up until you reach the what? Up until you reach the first term. Up until you reach the first term, which is a plus what? Plus a. Okay, plus a. So we have to add the equation, the first equation with the second equation. Sn is equal to this equation, and this is equation 1, and also this is equation 2. So we have to add the two equations. So when you add Sn plus Sn, give us what? 2n is equal to, therefore add the first term. Just choose any terms that you want to add, but when you add the first terms, we have to add the first terms only. When you add the second terms, you have to add the second terms only. This is the second term, and also the second term start here. This is the second term from the second equation, and this is the first term from the first equation. This is the first term, the second equation. So we have to add both equation, a, which means a from the equation 1 plus the first term from the equation to the equation 2, then plus a, let's say plus a, and all into a plus all into n minus 1 d. So 2n is equal to a, 2a, a plus a is 2a, plus all into n minus 1 d. Therefore 2n is equal to, not 2n, sum therefore divided, you're gonna put this is put bracket here and bracket here, because this stands for the nth term. We're gonna say n all into 2a and 2a plus n minus 1 d, 2a minus 1 d, divided by 2, both terms divided by 2, then you find Sn is equal to n divided by 2, the 2 from that side, open the brackets, 2a plus n minus 1, then you close the bracket d. So we have proved that the sum of the arithmetic progression is equal to n divided by 2 all into 2a plus n minus 1 d, which is the same as that one. It is the same as that one. This is general. Let's make, for example, another example without using formula. Let's say that Sn is equal to 1. Let's put values now. 1, let's say the second term is 2 plus 3 plus 4. Let's end them. Let's just end them. And then you say the second principle, say that Sn, this equation is equal to the second equation, which is, we're going to start from there, coming back to 3, 2, 1. Therefore, I'm going to put 4 plus, then 4 plus 3 plus 2 plus 1. So we have to add equation 1 and equation 2. We have added equation 1 and equation 2, but on this we're going to add this and the equation 1 and equation 2 in equation 2. But now we have values. 1 plus 4 is equal to 5. 2 plus 3 is equal to 5. 3 plus 2 is equal to 5. 4 plus 1 is equal to 5. That equation means this thing. This equation means this thing, which means when you add the first term with the first term of the second equation, the first term with the first term of the second equation will give you the same answer will give you the same answer with the second equation, the second values when you add both second values, second terms, and in both equation. I think this is clear. Let's go to the next equation. The next question said that you have to calculate the value. Calculating the value of sum of 50 terms. Sum of 50 terms where k is equal to 1 and 100 minus 3k. We are determining the sum of the 50 terms. So we have to find first the first three terms. When you substitute 100 there, when you substitute in place of k, you substitute 1. First, you have to substitute 1 in place of k. Therefore, we're going to say 100 minus 3. Therefore, substitute 1. Therefore, it's going to give us 97. Therefore, the first term will 97. The second term, then go and substitute in place of 1. 2. Substitute 2. Then the second term is 94. The third term, then go substitute 3. The third term is 91. Therefore 91 ... up until to the what? To the last term. The last term must be 50. Should be 50. The last term is 50. So substitute 50 in terms of k. In place of k, substitute 50 so that we can find the last term. To find the last term, therefore the last term is negative 50. It's negative 50. So to determine the sum of this series, you know that there is a constant difference of what? Of the 97 minus 94. 97 minus 94 is 3, then it's 3. There's a constant difference, which means we're going to use an arithmetic series. The sum of the arithmetic series. Which is Sn. Let's take this one. Sn is equal to n divided by 2. Therefore, first term plus the last term. Therefore, the number of 50 terms we divided by 2, all into the first term is 97 and the last term is what? Is 50. When you punch that in your calculator, say 50 divided by 2. 50 divided by 2 is 25. Therefore 25 all into 97 minus 50. 97 minus 50. Then it gives us 1175. Therefore, that is the sum of the 50th term of the 50 terms. So, if you don't want to use that formula, if you don't want to use this formula, you can use this formula. There's the one that we have proved above on question on 2.1. The one that we have proved on 2.1. This formula n is equal to 2a plus n minus 1 all into d. Just substitute all your values. You will see that you will find the same answer as this one, 1175. The next requirement, 2.3. The next requirement in 2.3, they say that we have to find a quadratic sequence. A quadratic sequence is defined with the following properties. T2 minus T1 is equal to 7. T3 minus T2 T2 is equal to 13, T4 minus T2 is equal to 19. Therefore, they asked you to determine T5 minus T4 in A, point A, T5 minus A. Therefore, let's go and try and 2.3.1. 2.3.1. We've given that they say that T2 minus T1 is equal to 7, and T2 and T3 minus T2 is equal to what? Is equal to 13. Therefore, and then T4 minus T3 is equal to what? Is equal to 19. Know that the first term T1 with the second term T2 with the third term T3 with T3 terms of the quadratic, and T4 and T4. We don't know these values. We don't know these values, but we know that there is a difference between these terms. These terms we have given the difference. When you say T1 minus T2, T2 minus T1, you find that difference, which is 7, and T3 minus T2, you find the difference of 13, and T4 minus T3, you find the difference of 19. So we have 7 and 13 and 19. 7, 13, 19. So they asked us to determine T5 minus T4. T5 minus T4. What is the difference? What is the difference between the T5 minus T4? T5 minus T4, let's add the T5. So we're trying to determine what? To determine this difference. This difference. Yeah, we don't know that difference. So we have to find the difference from this series, from this sequence. So 13 minus 7. 13 minus 7, we know that is 6. Then and 19 minus 13, we know that is 6. To find the following value, 13 minus 6, or 7 plus 13, 7 plus 6 is equal to 13. 13 plus 6 is equal to 19. 19, so we have a constant difference, which means that the second difference is constant in quadratic equation. Therefore 19 minus 19 plus 6, 19 plus 6 is 25. Therefore 25. Therefore T5 minus T4, term 4 is equal to 25. Then you find your mark. This is A. I think this one is clear. Let's go to B. In B, they say that we have to find T70 minus T69. T70 minus T70 minus T69. Term 70 minus term 69. How did we find the term 70 minus term 69? We're determining the difference. The difference here, the first difference, we know that this first difference, the first difference here is what? Is arithmetic progression. Arithmetic progression, we know that it have a what? A constant difference. But we know the first difference must have a general formula of the arithmetic series, which means Tn is equal to A plus N plus 1D. So we're gonna find the difference between between the term 70 and 69 by using this general formula of the arithmetic progression. Let's start. Let's find first the general formula. General formula is Tn is equal to, let's substitute in place of A, substitute 7, because our first term in first difference is 7 plus all into n minus 1, this n minus 1 here, n minus 1, The constant difference, say that the constant difference of this arithmetic progression is 6. Therefore, it's going to put 6 there. Therefore, Tn, or to determine, okay, we're determining the T70 minus T69. So to find the, okay, let's check our formula if our formula is correct. When we substitute in place of n, we substitute the first term to find this equation. When we substitute 1 there, 1 minus 1 is 0. 1 minus 1 is 0. Therefore, 6 times 0 is 0 plus 7. Then you find the first term. So, in place of n, you substitute the previous term, which means it is 69. And to find this value, in place of n, you're going to substitute the previous term, which is 2. So, in this problem, in this one, you're going to substitute 69. Therefore, 7 plus all into 69 minus 1, 6. Therefore, let's punch the calculator. Say that 7 plus all into 69 minus 1 all into 6. Times that brackets by 6, then you got 415. Therefore, 415. Therefore, 415. Find that 415. Therefore, T70 minus T69 is equal to 415. Is equal to 415. I hope this one and also this one is clear. Let's go to the next question. Okay. In 2.3, they say that we have to calculate the value of the T69. Calculate the value of T69. If calculate the term of T69, determining T69, which means determining the term of the value of T69 there. That value, they want to know what that value of T69. So, if T89 is equal to 23,594, we have to use this value. They gave us for a reason. So let's solve it. Let's try to find the value of T69. To find T69, we're gonna say 23,594 minus all the previous sum from 69 to 89, all the previous differences from 69 to 89. So, which means say that we're gonna say T89. Term 89 that they give us minus the sum of all differences, the sum of all differences of all previous differences. Add the sum of all previous differences, then you subtract to that value of the 89th term. So the 89th term is 23,594 minus the sum. You know that first difference and in quadratic equation is the arithmetic progression. So we have to use the formula of the arithmetic progression, the sum, the series of the arithmetic progression, and divided by 2 all into first term plus the last term. Then we cross bracket. We close the bracket. So let's substitute 23,059 for minus all into n. How many terms from 69? We said that 69 to what? To 89. So we'll take a calculator. 69 minus 89. So you're determining the sum of the 20th term here, the sum of the 20th term, which means 20 divided by 2 all into the first term. We know that the first term, we say that from 69, the first term difference there is 214. Take that 214. 214 plus the last term. Determine the last term. How are we going to determine the last term? The last term of the arithmetic progression on first difference. Use the formula of the arithmetic progression, which is a plus n minus 1 d. We know that a is what? A, the first term was 7 plus the number of term up until to the last term up until to 89. Up until to 89, so we're not going to substitute 89, we're going to substitute what? 88. So 88 minus 1, the difference, we know that the difference, we've already calculated the difference on the first difference of the arithmetic progression, which is 6. So punch everything there, so that's 7 plus all into 88 minus 1, close the bracket, then close the bracket, then you times all by 6, then you got 529, therefore is 529, then you close the bracket. Therefore determining the T69, therefore T69 is equal to therefore 23,594 minus, let's punch everything for this one, is 20, which means 10 all into 214 plus 529. Then our solution is 7430. I think it's correct. 7430. Therefore, 7430, 23,594 minus 7430. And I'll say that minus 7430 is gonna be 16,604. I think this is the right answer, or this is the correct answer. Sorry. There's a mistake somewhere. This is not 214. We didn't find 214 on the previous question. We found we found 415. So there must be 415 there. 415. Then substitute. Just change here. 415. 415. Therefore, which means this answer will change. It's gonna change. So let's punch again. Sorry. So we're gonna 415 plus 529 times 10, which means it's gonna give us 944.0. Therefore, which means this answer will change. Therefore, T69 will be equal to therefore 20,000 minus 20,594 minus 9,440 minus 23,594, which means give us 14,150 and 54. Therefore, that's our final answer. I hope this is clear. I hope this is clear. This is clear. Just try and do and practice it and analyze it properly. You will find it correct. You will find it correct. Just use your brain. Use your brain. Thanks. We will go and watch part 1 before and watch part 2. Then part 3 is coming tomorrow. Which is question 3 of this paper, 3rd March 2015. So my name is Tamo Mfuneko.